Hello, hello, my lovely students. So I miss you a lot. I wish I was with you, but this is the next best thing. I'm going to go over the rules of exponents so that by the end of this, you can rewrite expressions involving rational exponents using properties of exponents. So the first thing we need to talk about is our vocabulary. A monomial, Mrs. Coyle is having struggles reading things. I'm just not going to say the word. That thing is a number, a variable, or a product of a number and one or more variables. In other words, when you have 34xy or 7a squared b. All right, but the most important thing here is that we understand what an exponent and a base are. The base is the large number like this 5. Exponent is the small number above like this 2. So, product, rules of exponents. There's the product of powers. What this means is that if you're multiplying two of the same base, then you're going to add the exponents. So, in other words, here I have a to the m power times a to the n power, which means we have a to the m plus n power. So let's look at that if we've got actual numbers. I've got 5 to the power of 2 times 5 to the power of 6. So, because of the product of powers, we now have 5 to the power of 8. Because 2 plus 6 is 8. I'm looking at y. I have y to the power of 4 times y to the power of 3 times y. Now, there is an invisible exponent here. The exponent is 1. Don't forget it. So, I'm going to see if I can zoom in a little bit because I know this is kind of small for you guys. Oh, I guess I cannot. Well, there we go. Okay. So, in other words, we have y to the power of 4 plus 3 plus 1. 4 plus 3 is 7, plus 1 is 8. In other words, my answer would be y to the power of 8. All right. Here we have 7y to the power of 5 times 6y to the power of 1. So, I'm going to take. All right, so when we are looking at this, we have 7y to the power of 5 times 6y to the power of 1. We're going to multiply 7 times 6, which is 42y. And we're going to add our exponents. So 5 plus 1 is 6. So we end up with 42y to the power of 6. All right, over here, we have negative 3x squared y 7, 5x to the power of 1, y 6. So I'm going to multiply negative 3 times 5, which is negative 15. X 2, so 2 plus 1 would be x to the power of 3. And y to the power of 7 plus y to the power of 6 would be y to the power of 13. 7 plus 6 is 13, right? Okay. Sorry, I had to call on Mr. Coyle here for a second. So y to the power of 13. And that's your answer. So product of powers, remember, you're multiplying the two numbers with the same base and then adding the exponents. Let's look at the quotient of powers. In the quotient of powers, if you're dividing two numbers with the same base, you then subtract the exponents. So we have y to the power of 6 divided by y to the power of 1. So we take y to the power of 6. 6 minus 1 is 5. So we have y to the power of 5. 6 to the power of 13 and 6 to the power of 2. 13 minus 2 gives us 6 to the power of 11. All right, here we have some extra pieces with A and B, but again, we are working A to A and B to B. We have 10 a to the power of 7, a to the power of 5. 7 minus 5 is 2. So we have a to the power of 2. And then we have b to the power of 9 minus b to the power of 9, which means our b's cancel out. 15 remains on the bottom. And I just broke my pencil. This is why you always have a backup. Now, I'm looking at this. I can simplify it further. So I can divide 10 and 15 both by 5. So I get 2a to the power of 2. Struggling here, guys. Over 3. So my final answer is 2a squared divided by 3. Okay, let's look at our next page. Zero exponent. Okay, so I wanted to cover this quickly, but we're not going to focus a whole lot on zero and negative exponents because that's something you're going to do a lot in 8th grade. So the zero exponent basically just tells us that any non-zero exponent, any non-zero number with an exponent of 0 is equivalent to 1. So we're going to skip the y. Let's explore. If I look at this problem here, it tells me that this entire thing, when solved, is to the power of 0. Thus, the entire thing is equal to 1. Now, here is a little different because this is just x to the power of 0. So in other words, x, no matter what x is going to be 1. So 8 times 1 is 8, plus 5 would give me 13. So if you see that zero exponent, you end up with 1. Now let's look at negative exponents. For any non-zero number raised to a negative exponent, we place the power in the denominator to rewrite the power with a positive exponent. So if I have a to the power of negative n, I rewrite it as 1 over a to the power of n. So we're not going to do the y. Let's explore again. If I look at 2 to the power of negative 3, I rewrite this as 1 over 2 to the power of 3. If I'm looking at negative 3 to the power of negative 3, again, I place 1 over negative 3 to the power of 3. All right. What I want you to take away from this is if I see a negative exponent, I need to change the place and flip the place of that exponent. So this actually also works if I were given a negative exponent and it was something along the lines of 1 over x to the power of negative 1. We'll do 2 just for visual purposes. In this case, you would actually change it to be x to the power of 2. It changes the placement. That's what I need you to take away from this. Not something we're going to focus on. You might only see 1 or 2 questions on your test about this. And last but not least, power of a power and power of a quotient. So if raising a power to a power, you multiply the exponents. So I have x to the power of 2 to the power of 8. 2 times 8 is 16, so I actually have x to the power of 16. Ooh, I have power of negatives, okay? So y to the power of negative 3 to the power of negative 4. Negative 3 times negative 4 is positive 12. So I have y to the power of 12. Again, going back to those integer rules, make sure you know those. If you don't, I highly suggest you practice. All right. So we have to find the power of each factor in the parentheses and multiply. So 4 to the power, 4x to the power of 3, y to the power of 1, z to the power of 1. So we end up with 4 to the power of 3 is 4 times 4 is 16 times 4 is 64. Remember, you may use a calculator. So we have 64x to the power of 9 y to the power of 3, z to the power of 3. Because 3 times 3 is 9, 1 times 3 is 3, 1 times 3 is 3. All right. Looking over here, I have 7 to the power of negative 2. Okay, so number 1, actually, we're not going to do these two because I feel like they are, number 1, way too complicated, and they use a lot of negative exponents where we're not focusing. So what we need to understand here is that if we have a number inside of the parentheses to a power, we also need to take the power of that number. So in other words, 4 also needs to be taken to the power of 3 to get 64. 7 would need to be taken to the power of negative 2, which in this case would be 1/14th, but we're not going to focus on that part. All right, power of a quotient. The power of a quotient for any numbers, a and b, where b does not equal 0, if the quotient of a and b is raised to a power, raise both the numerator and denominator to the given power. So if a over b to the power of m is also equal to a to the power of m divided by b to the power of m. So we have 3/5 to the power of 2. So in other words, we have 3 to the power of 2 over 5 to the power of 2, which is also 9 over 25. Okay, over here, 2a to the power of 5 to the power of 2, and b to the power of 7 to the power of 2. So we need to take 2a to the power of 5 and multiply it by 2. So we end up with 2 to the power of 2 is 4. Multiply 5 times 2 to get a to the power of 10. Ooh, not 11. Mrs. Wells writing fine. B to the power of 7, multiply 7 times 2 to get b to the power of 14. So what we're doing is we're making sure that we understand that this power applies to both top and bottom now. If I'm looking at, I'm not going to do these two bottom ones because they work with negatives, and that is not something we're going to be focusing on. So we're making sure to apply this to every piece of what's inside the parentheses, as I've been teaching you anyway, so that shouldn't be any new information. All right, guys, so you have some practice that I'd love you to work on, and I hope you have a great rest of your day. Bye.